Hey everyone, Dave here. I want to go over the Neo Debugger now. So the Neo Debugger is another City of Zion tool that allows you to do a little bit of debugging of your smart contract, which is great. If you've done a little smart contract work already, you've probably run into calling a method and it just returns a fault and you have no idea why. So the Neo Debugger can be really handy for being able to step through your code and see what's going on there. So you can get that from the GitHub page, the City of Zion site there. Now, I've downloaded all the source code here. I got it open here. One of the first things we need to do is build the compiler. So this comes with a custom compiler that will generate both a AVM file, like we've done before, but it also outputs a debug.json file. And this will map the opcodes in the AVM to lines of code in our source here. So it's really important to make sure that we build that. Now, if you watch my previous video, I mentioned how to do your own custom compiler as a post-build action, and that way you can swap between which compiler you're using. Typically, if you follow the Neo directions, you download their compiler, you build it, and then you set your path environment variable to point at that one here. So if you do now, you got to go adjust that path environment variable to this debugger, which is going to affect all projects. So it's a little bit of a hassle, I find, especially when you want to switch back and forth quite a bit. And then you got to make sure that you did it. And does your computer require a restart to take that environment variable? So every time you're swapping, do you have to do reboots? You know, a little bit of a pain there, but I'll show you how to do it here. One of the things is they ship an ICO template here, just a regular Neo project here. And what I'm going to do, just a regular smart contract, is I'm going to convert this from just the Neo project type and remove some of those customizations in it so that we can manipulate this. So you'll see here in the after build, we call this convert task. That's what's going to call the whatever compiler it finds first, which we don't want. So I'm going to remove that. I can also optionally remove this item group to include the Neo convert task.dll, which I'm going to do. Save that. I'm going to right click on the project and reload it. Yes. I don't need this open right now. And so what I'm going to set up now is a post build action. So open up this project, post build. Do I still have that? I do have that in my clipboard. So now here as a post build, we're going to run the Neo compiler bin debug neon.exe with the target path. So whatever DLL we're building, save and close that. And let's build this. We'll go look at our output. And so we should see our AVM get generated as well as the debug.json. And I believe the compiler will also tell you in its output that it is the debugger. So it's important to look at that and make sure that you are using that debugger and it's not going to the Neo provided Neon compiler. This is taking a minute as usual. While that is going, I'll just show you another neat thing that I've discovered with this is that they actually do have a little bit of stuff here to do unit testing against this because it is using basically an emulator. So they do create an emulator here. And you can see here that they're loading in their AVM, they're creating a new blockchain, they're creating a new emulator, they're deploying a contract, and then I'm not sure what this is doing, is I'm assuming the address, because that comes back from deploy contract, is the actual contract itself on the blockchain. And then they've got a little bit of code here that is going out and testing, calling the symbol method. So I think it's passing in the first value is the string of symbol, and the second value is the param array that you would provide, and they're passing in null. So it's kind of neat that they've got this here. I've never really used this, but I can see how it would be handy as long as it's accurate. So let's look back at our output window here. So our compiler did run, so you can see here it's a version 1 debugger support, and it compiles this and generates an AVM, an ABI.json. So that ABI file basically details all the methods that are available in the contract, and this debug.json maps all the line numbers to your source code here. So with that being done, I'm going to start up the WinForm application here that will let us interactively debug this contract. Just give that 1 second to fire up. Okay, so that's up and running now. And you can see here that we get this little environment. You can actually use this as an IDE and change it and compile it. I've been having a few issues with it. I like using Visual Studio myself, but you can do work out of here. So what I want to do is I want to step through this code. And there's a deploy method. You can see it takes no parameters. And I'm going to step through that. So now you can just use your keyboard